So we're going to continue in our factoring thread here because, again, I talked with some Algebra 2 teacher, just talked with an Algebra 2 teacher, and he said that a good kind of emphasis would be to talk about some factoring here. And so specifically factoring quadratics. Okay. Okay. So really, we call these things trinomials, but they're also quadratics as well. So I'm not really sure why, because trinomial makes sense to me. Trinomial means there's three terms, right? So it's like, that's obvious, okay? And so today, we're going to be factoring trinomials of the form ax squared plus bx plus c, where a equals 1 and then b and c are integers. Okay, so here we're going to focus on just our lead coefficient, the lead, the one way out in front here, in front of the highest powered term. That's the lead coefficient there. We're going to focus on that just being 1, okay? It gets a little bit trickier when we change it, when we change a to not be 1, like 2 or 3 or 4 or whatever, but we're not going to worry about that today. We'll worry about that tomorrow, okay? We'll get to that tomorrow, okay? So we're going to stick with just a being 1 here. So again, it's pretty obvious, okay, this is obviously a trinomial, right? 1, 2, 3 terms there. Not really sure where the word quadratic comes from, especially because the prefix quad means 4. So I'm like looking at this and thinking, I don't know where you get 4 in there, but maybe that's something I should look up and figure that out, okay? But at least trinomial makes sense, right? So the methods I'm going to show you here, we will get to some trinomials not with a not equal to 1. Okay, and I'll help you with that too. Okay. So the one way you can think about, one way we kind of like factor these, or what we know about these, I guess. So it's going to be today, to start out at least, we'll focus on problems that look like this. Okay, x squared plus bx plus c. And we know that these things, if they factor, they'll factor to 2 binomials. Okay, they tend to factor to 2 binomials. Okay. We know that we need an x squared, and so we know that we're going to have an x here and an x here in front of the binomial to get that x squared term, right? But then we're going to need a number here and a number here. Okay. And what do we know further about these two numbers? These two numbers, how must they combine together according to the information we have right here? So let's maybe call this like m and n. So how do m and n result in some of the numbers over here? Okay, so m times n must equal c, and what else must be true? M times n will give us c. Avery?
Plus n.
Yeah, very good. M plus n must equal b, right? You add these two numbers to get the middle term. You multiply the two numbers to get your last term there. Okay? That's exactly right. All right? And so this method is called the product sum method that I'm going to show you here, right? Product sum method. Okay? Product sum method. Okay. So we'll do an example. Okay, so let's say we want to factor x squared plus 6x plus 8. Okay. Now, The first thing we should kind of recognize here is that it just says generically factor. And remember, factor means a lot of different things. So for example, factoring out a GCF, a greatest common factor, that is factoring, right? Do we have a greatest common factor we can factor out here? Is there something that we can take out of all three of these things? That's shared in common by all three of the terms here? Was there one thing we could divide out all three of those terms by? Just one, right? So one, but everything is one. So nothing that's not trivial, right? One would be true, but it doesn't really help us at all. Okay? So yeah, so there's no GCF. Could we factor this by grouping? Is this a good candidate for grouping? Yeah, not really. I mean, we could group together, the first two and take an x out of that, but then we would have x times x plus 6 and then a plus 8 on the outside, and then we don't have two common factors to then factor out again. We could group the 6x plus the 8, right? And factor out 2 from each of those. But then again, we'd have x squared plus 2 and then parentheses 3x plus 4. Again, it just doesn't quite work out right, kind of thing. It doesn't quite work out right there. So we're going to try now this product sum method, right? So we need two numbers, okay, that multiply to give us, two numbers that multiply to give us 8. And we also need two numbers that the same two numbers that must what to 6? Add to 6. Okay, and I know this is maybe like breaking it down way easier. Maybe you guys have already figured out the answer. Maybe you did 2 minutes ago, and I've just been talking and on and on and on, and you're just bored out of your mind. Well, but anyway, I like to go through this thoroughly here, just for others too, okay, in case maybe this is news to you. Okay. You'll notice I numbered these two. I said I started here with number 1 by saying we need two numbers that multiply to make 8, and then we think about the same two numbers that then also have to add to make 6. Why don't I go in reverse order? Why don't we start by looking for two numbers that add to 6 and then seeing if they also multiply to make 8? Why don't we go in reverse order there? Any ideas about that? There is a strategy here. Yes, Stephen?
There's multiple ways to add to 6.
Right. There's in fact, there's how many, so if we take the number of ways you can add to 6 and the number of ways you can multiply to 8, there's way more ways to add to 6 than there is to multiply to make 8. Exactly right. And Avery, is that what you're going to say too?
Yeah.
Yeah. So it's just more efficient that way. It's more efficient that way. So, what are two numbers that multiply to make 8? Okay, so what's that? 1 and what? 1 and 8. Okay, so 1 and 8, they multiply to make 8, but do 1 and 8 add to make 6? Nope. And so the answer there is not 1 and 8, right? And so we don't want to use this. All right, so instead we'll jump over to there. What's another pair of numbers that multiply to make 8? 2 and 4, right? And so then x plus 2 and x plus 4. And do they add to make 6? 2 and 4 do make 6, right? Okay. And again, you can check yourself. If you FOIL it back out, right? If you FOIL this out, it'll result in that x squared plus 6x plus 8. Okay. So that's our purpose there. All right, let's try another one here. And let's try y squared plus 91y plus 90. Okay, so again, we already know we're going to need a y here and a y here. Okay. And so now we need to think of two numbers that multiply to make what? 90. Ugh. And then add to make what? 91. Okay, so multiply to 90, add to 91. And what would those be? 1 and 90, 90 and 1. Exactly right. Okay, this is why it's really helpful to know your multiplication, kind of, I guess, facts or whatever. Makes it a lot quicker. Okay, and so there it is factored. All right, let's try another one here. e squared minus 7e plus 10. E squared minus 7e plus 10. Okay, so now we're trying to multiply to what? 10, but add to make a negative 7. Negative 7. So, to multiply to make 10, what are some numbers we can use to multiply to make 10? 5 and 2, okay? But 5 plus 2 is positive 7. There you go, negative 5 and negative 2, yeah. That's a tricky one there, or it can be tricky, right? At least when you guys were first learning this, maybe, right? That not only do not only do a positive 5 and a positive 2 multiply to make 10, but a negative 5 and a negative 2 also multiply to make positive 10, right? And so when you see a situation like this, where you have a negative middle term and a positive third term there, we know what's going to be true about these two numbers here. They'll have to be what? If you add to a negative number but multiply to a positive number, what do you know about these two numbers? They have to be what?
Negative.
Both have to be negative. Both have to be negative. Exactly. Both have to be negative. All right? All right, let's try another one here. All right, how about 5b squared minus 30b plus 40. Okay. Now I've kind of thrown a little wrench into the mix here, haven't I? Because if we're trying to factor this thing, we now have a lead coefficient. We have a 5 there, all right? And we haven't gone over how to do that. Maybe you know how to do that. Okay. Jenny? Ah, yes, right. So in this case, remember our directions were just to factor. So we have a GCF here. Very good. So let's factor out that GCF. So let's take that 5 out. And now we have b squared, right? Our lead coefficient now for that b squared term is just 1. That leaves us with minus 6b and then plus 8. Excuse me. And so now when we go to factor this, we can focus, not on the 5, we can focus on b squared minus 6b plus 8. And so now we're looking for two numbers that multiply to make what? 8 and add to make negative 6. So what are those two numbers? Negative 2 and negative 4. And there's our answer. With the, don't forget to put the 5 in front, right? The 5 is still there. It's part of the expression. But you just leave it out front like that. Okay. It's all one big product there. All right, you guys ready to try one on your own here? Try two on your own maybe. All right, so you guys try these. Excuse me. So again, factor is your directions, or are your directions. Let's say x squared plus 3x minus 54. And I had one here too, yes. Actually, I'm going to give you 3. N squared plus 13n plus 36. And then number 3, I'll put it right down here. C squared plus 7c plus 7. So yes, give those a try. Give those a try. Okay. Let's see what we came up with here. Let's go to Chrissy. Chrissy, number 1. Did you get it to factor? Oh, you didn't finish number 1? Okay, sorry. Am I going too fast? I'll give you guys some more time. Give me like a minute or two, please. Okay.
Okay.
How come
it's
it's-
supposed to? Oh, oh, never mind.
Got it?
Yeah.
Okay. Right. Right. One more minute. One more minute. One more minute. One more minute. Bless you. Chrissy, were you able to figure it out? All right, Chrissy, what do you got for us now for number 1? Aha, so x minus 6 times x plus 9 is what you see. Okay? Everyone okay with that? All right, so yeah, it's a little bit like counterintuitive, right? So Aubrey, was like unsure about it, right? It's a little counterintuitive to think you have to multiply this ginormous number, but then add to this tiny number, right? But it's helpful because we have that negative, so like one's gonna be opposite from the other, and so they'll add to make a small number kind of thing. So yep, very good there. All right, how about Brandon? How about for number 2? Were you able to get number 2 to work for you there?
9 and 4.
9 and 4. So n plus 9, n plus 4, like that? Okay. And then how about Anna for number 3? Get that one to work for you? No. Yeah, that's because it's impossible. Yeah, so can't be factored. Sorry for those of you that were racking your brains. Probably caused like a little panic attack or something like that I was going to call on you for that one. Okay, can't factor it. All right. There's no way you can multiply the 7 there. Well, there's no number that multiply to 7 but also add to make 7, right? So it doesn't factor. All right. Question? Emmanuel? Never mind. Okay. So there will be later, of course, there will be, of course, like if this were an equation, if it were equal to something, let's say like it was like equal to 0, right? And if you wanted to solve for the values of c that would make the equation true, typically you would again factor and then set each factor equal to 0 using the zero product property. But for something that doesn't factor, you don't just give up on it. All right, we learned something called the quadratic formula, and we can use that to help us determine solutions sometimes. They may not be nice integer numbers, right? But sometimes they're irrational numbers. Sometimes they're imaginary too, though. But anyway, don't have to worry about that right now. Okay, that's beyond what we need to worry about. Okay, other things I want to talk about real quick before I finish up and get you guys started on your assignment. I also want to talk about a special situation. When it comes to factoring. Okay, something called a difference of squares. And you maybe have heard this before, right? That's when we have something like x squared minus, I don't know, I'll just make it up here, 25. So a difference of squares, we call it a difference of squares because it is a difference of squares, right? X squared is a perfect square. 25 is also a perfect square. 25 is the square of what? 5, right? Okay. So you can factor this. All right, you can learn like a special rule for it if you want to, or you can just recognize that this is a quadratic. Okay? It is a quadratic of the form x squared plus, now there's no x term, and so there's no x term, what number should I put in front of the x? 0. And then minus 25. So as soon as you realize that x squared minus 25 is really x squared plus 0x minus 25, it's a quadratic. You can now factor this thing as if, using our previous rules, right? Here, we're looking for two numbers that multiply to make what? Negative 25, but add to make what? 0. So what are two numbers that multiply to negative 25, but then add to make 0? Negative 5 and 5. So x minus 5 and x plus 5. Exactly right. That's the idea. Questions on any of that? I don't want to do too much more than that, so that's fine. That's fine for right there. All right. I wasted a whole sheet of paper for that. So I think you guys get the idea from there. All right, very good. So I'm going to get you guys started on your assignment. I have to scan it first, and then I'll put it into the Google Classroom. So I'll let you know here. So just hang tight for 2 seconds while I get these scanned and put into Google Classroom. Don't forget, you also have a TenMarks that's due Friday, so make sure you're working towards that. All right.